Okay, your other half of homework, page 622, number 9. And you're going to need the chart on the previous page. A sample of 1 gram of tritium, so M initial is 1 gram, is produced. What will be the mass of tritium remaining after 24.6 years? So the delta T is 24.6 years, and it's looking for M final. So we know that the number of half-lives is equal to the delta T over the time for one half-life. And if you look back on your chart on the previous page, you'll find out the time for one half-life is 12.3 years, which is very convenient because it means N equals 2. Okay? So MF is equal to MI over 2 to the N. So MF is equal to 1 gram over 2 to the 2, which is about 4. So 1/4 of a gram, or 0.25 if you'd rather. Number 10. The isotope of, what is that, 238 neptunium has a half-life of 2 days. So this time it's telling us T to the 1/2 is 2 days. 4 grams are produced on Monday, so MI is 4 grams. What will be the mass of neptunium remaining on Tuesday of the next week? So Tuesday of the next week will be 8 days later. Okay? And so our number of half-lives, delta T over T to the 1/2, is equal to 8 days divided by 2 days, higher order math here, and you get 4 half-lives. So now we go MF is equal to MI over 2 to the N, so 4 grams over 2 to the 4th. 2, 4, 16, 32. So 4, I think 4 grams, doing this in my head, and it's kind of late at night. Is that, I don't know, I better check 2 to the 4. 2 to the 4. Oh, it's 16, I went 2 to the 5. 2, 4, oh yeah, 2, 4, 8, 16. And so MF is equal to 1/4 of a gram. Wait, that's what we got up at top. Number 11 says, a sample of polonium-210 is purchased for a physics class on September 1st. The activity is 10 to the 6 decay. So remember how we talked about, doesn't always have to be grams, it can be activities too. So I'm going to call it A, and that'll be AI, is 2 times 10 to the 6th, what was it? Decays per second. So decays per second. I think that's called a Becquerel, maybe. The sample is used in an experiment on June 1st. Seriously? So we're going from September 1st to June 1st. So the hard part of this question is figuring out the delta T. And it wants to know what activity can be expected. All right, so 30 days has September, April, June we don't need, and November. So those 3, all the rest have 31, so that means October and December and January, except for February, has 28, March 31, we did April, May 31. I think it's 273 days. I think I did that right? And I trust you all know the song, 30 days has September, April, June, and November, all the rest of 31 except for February. But leap year comes once in 4 to give poor February 1 day more. Okay, so you need to flip back and find polonium-210 on the chart, and when you look at polonium-210 on the chart, you find out its half-life is 138 days. So we can now find how many half-lives have passed. So 273 over 138 is not going to work out pretty. Wonder if they wanted it to be a leap year. Still wouldn't. Should have used it on June 3rd, and then it would have been, or June 4th. So n is equal to 1.978. So now we go, we're going to call it AF is equal to AI AF is equal to AI over 2 to the n. So AF is equal to 2 times 10 to the 6 decays per second over 2 to the 1.978. And no, you should not round that. You can actually leave it all in your calculator and raise it to 2 to that. And I think you get 5.0759 times 10 to the 5th decays per second. Okay, so your AF. All right, number 12, tritium. Tritium, which is 3 hydrogen, hydrogen 3, was once used in some watches to produce a fluorescent glow, so the watch could be read in the dark. If the brightness of the glow is proportional to the activity of tritium, what would be the brightness of the watch in comparison to its original brightness when the watch is 6 years old? Okay, so delta T is 6 years. We already used, I think, tritium up top, didn't we? And it was 12.3. Is that tritium? Yeah. So the half-life is 12.3 years. And so we can get the number of half-lives, delta T over T1 half, 6 years over 12.3 years, and you'll get an N of 0.48780. Okay, so now we go to MF is equal to MI over 2 to the N. But this is one, like I was telling you in the video, it wants the comparison to the original brightness. So divide both sides by MI. MF over MI will give us the comparison, how bright it is compared to what it was. Or maybe it's AF, I guess, because it's talking about activities, over AI. It doesn't really matter. Either of them are going to be equal to 1 over 2 to the n. So it's going to be equal to 1 over 2 to the 0.4878. Okay? So activity final over activity initial will be 0.7131. In other words, 71.31% as bright as the original. Okay, so there are more of these to do and some binding energy ones, so you'll get more practice.